What's up, my beautiful people? Dilo here from Rincon de Armas. This is FTT122, Intro to Ballistics and Ammunition, Week 4 assignment, and we'll be going over what the industry calls stopping power. There are three more common known formulas for stopping power. Of course, they've been developed over the last century, and we'll start with the first one, which is the TKOF, John Pandoro Taylor's mathematical formula approach that he developed basically in the middle of like the 20th century for evaluating stopping power of hunting cartridges on elephants. So his formula devised as a means of comparing the ability of a cartridge to deliver a knockout power to a large animal like an elephant from a shot to the head, even when missing the brain. Well, the bullet mass is measured in grains times the velocity, which is measured in feet per second. That is times the bullet diameter, which is measured in inches. And then it divides the product by 7,000, which is the number of grains per pound. Now, another big game hunter in North America and Africa was Peter Thornley, and he developed a calculation known as the Thornley stopping power factor, otherwise known as TSPF. And it had nothing to do with stunning large game with headshots. Rather, it considered stopping power in terms of a well-placed body shot. And the Thornley formula was the constant, roughly about 2.866 times velocity times bullet mass divided by 7,000 times the diameter of the round, right? Then we have the third one that I found, which was the Hatcher's relative stopping power, also known as RSP, which was developed by Major General Julian Hatcher of the United States Army Ordnance Training Center. His formula is most pertinent to handgun ammunition, as it is the only one that factors in the bullet shape and type, which is certainly an important consideration when talking about stopping power, specifically for self-defense. Momentum of the bullet is also factored in. So the momentum of the bullet is in foot-pounds per second, and it is calculated at between mass times velocity. Then we have the acceleration due to the gravity in feet per second. Then we have the frontal area of the bullet in square inches, and then the bullet's form factor based on a list of bullets created by Hatcher himself. Do I agree with the formulas that may exist? I do agree to a certain extent. From my research, it does seem to have mixed reviews, like the Taylor factor for the elephants. It seems to have a lot of different mixed reviews because the formula does dismiss like muzzle energy. And then he did acknowledge himself that in the case of soft-skin non-dangerous game, theoretical mathematical energy may possibly prove to be more reliable guide, being that his formula was designed to measure a cartridge performance against large game, like an elephant. As modern ballistic science altered the way the term or concept can be measured, term stopping power. In a way, I believe that modern ballistic science has been centered around the ability to place one shot to center mass in a self-defense scenario for defensive purposes. The FBI has declared that the 9mm, the 40 Smith & Wesson, and the 45 ACP are all equivalent in that category and have had numerous tests to back them in most common rounds used for self-defense for decades now. There will be people who disagree, specifically generations who grew up with the 45 and the 1911. It has that stopping power. I personally believe it is a slower round. It's been proven to be a slower round, but you do one shot to do it, right, in self-defense. 9mm does depend on grainage and stuff like that, which can qualify the same. And then the FBI really backed the 40 Smith & Wesson for a couple decades. And then the 9mm became a little bit more well-rounded and more respected as the most common used self-defense round. It is important to learn these kind of things depending on what your needs are. If you're hunting and you need larger cartridges, or if you're just carrying daily for self-defense, you need to understand your ballistics. Thanks for watching, guys. This has been week 4, and I'll talk to you guys soon. Happy shooting.